An automated system is a combination of hardware and software that carries out a task without human intervention. That last phrase is the whole definition, and it is worth testing against something familiar. A washing machine you load, set going, and walk away from is automated. It runs its program, monitors temperature and water level, and stops by itself. A drill is not, however, powerful because it does exactly what you do with it and nothing more. The three ingredients are always the same, and we have met all of them separately in topic 3. Sensors, which measure a physical property continuously. A microprocessor, which compares those readings against stored values and decides. And actuators, which carry out physical actions. This lesson is really about what those three become when you put them together and take the person out of the loop. The loop itself we covered in detail in topic 3.2, so a summary here. The sensor takes a reading. An analog to digital converter turns it into something the processor can accept because sensors produce analog signals and processors are digital. The microprocessor compares the reading against a stored preset value. If action is needed, it signals an actuator, and then it repeats continuously, taking new readings indefinitely. Two things to keep saying in answers, because both are commonly dropped. First, the ADC step, data from the sensor is converted to digital so the microprocessor can understand it. Second, that the process repeats. A system that checked once would not be automated. It would have made one decision and stopped. The repetition is what lets it hold a condition steady over hours or years without anybody present. The syllabus wants applications across named sectors, and the useful thing is that each sector explains why automation was worth introducing there. In industry, robots on production lines weld, paint, and assemble, chosen for consistency and for the ability to work continuously. In transport, automated systems manage traffic lights, railway signaling, and aircraft autopilot, where the reasons are precision and reaction speed beyond human capability. In agriculture, automated irrigation waters when moisture sensors fall below a threshold, and greenhouses control temperature, humidity, and light, the reason being precision applied over a large area at low cost. In weather stations, sensors record temperature, pressure, humidity, and rainfall continuously in locations nobody could staff. In gaming, sensors detect motion and orientation to control gameplay. In lighting, street lights switch on as light sensors detect dusk. And in science, laboratory equipment monitors experiments over long periods and records data at intervals no human could sustain. Notice the pattern across all of them. Automation is chosen where a task is repetitive, needs to run continuously, requires precision, or happens somewhere inconvenient or unsafe for a person. The advantages follow from that pattern. Automated systems work continuously without breaks, holidays, or fatigue. They are consistent, performing a task identically every time, where human performance varies with tiredness and attention. They react faster than a person. A sensor and processor respond in milliseconds. They are more accurate for measurement and repetitive precision work. They can operate in environments that are dangerous or simply uninhabitable. Inside a furnace, underwater, in a reactor, in space. And over time, they reduce running costs because the same task no longer requires paying somebody to do it. That last one is why automation spreads even where the other reasons are weak, and it leads directly into the disadvantages. The disadvantages are real, and a good answer gives them properly rather than as an afterthought. The initial cost is high, equipment, installation, and setup, which is why automation suits high volumes where the cost is spread. Specialist skills are needed to program and maintain the system, so an organization trades many low-skilled roles for a few highly skilled ones, which is a genuine social change and not merely an accounting one. Systems are vulnerable to faults. If a sensor fails or gives a wrong reading, the microprocessor acts on bad information and may do exactly the wrong thing confidently. There is a loss of flexibility since an automated system does what it was programmed to do and cannot improvise when something unexpected happens. And there is unemployment, where automation displaces workers whose skills may not transfer. Notice that several of those are the same properties listed as advantages, seen from another angle. Consistency means it will repeat a mistake as reliably as it repeats a success. Working without human intervention means no human notices when it goes wrong. So, how do you answer a scenario question here? You will be given a situation and asked whether an automated system is suitable or which sensors it would use, and the reasoning is the same each time. Ask what physical property must be measured. That gives the sensor. Ask what physical action must result. That gives the actuator. Ask what the target value is. That is the preset value. Take an automated greenhouse. Properties: temperature, humidity, soil moisture, light. Actions: open a vent, switch a heater, run a pump, turn on lamps. So temperature sensor with heater and vent motor, moisture sensor with water pump, or take a car park barrier. Property: is a vehicle present and is the ticket valid? Sensor: an infrared or pressure sensor detecting the vehicle. Actuator: a motor raising the barrier. Name the sensor by what it measures, never as just a sensor, and name the actuator by what it does. Those two specifics are almost always where the marks are. 4 things to take into the exam. First, define an automated system as hardware and software carrying out a task without human intervention. That final phrase is the one being marked. Second, always name the 3 components and what each does. Sensors measure, the microprocessor compares and decides, actuators act. Never let the sensor make the decision. Third, include the ADC and the repetition in any description of how the system works. Both are routinely dropped and both are usually worth a mark. And fourth, when evaluating, give the disadvantages with the same specificity as the advantages: high initial cost, specialist maintenance skills, vulnerability to sensor failure, inflexibility, and job displacement. An answer that only lists benefits is answering half the question.